morning, everybody. We are the team from the Zhejiang University, and I'm very glad to be here to present our team's project to you, an energy-saving electric kettle based on heat transfer by heat pipe. Well, before we start, I'd like to take this opportunity to introduce our team. Our captain is Yin Zhichao, and there are 3 other teammates in our team. They are Yang Ye,黄崇德, and I am Jin Yang. Our instructor teacher is Professor Xiong Shen. Next, I'd like to give you a brief preview of my presentation. There are 4 parts: the background information, the theories behind our energy-saving kettle, and the innovations inside our kettle. Finally, we have conducted several experiments to test the energy efficiency of our electric kettle, which means how much energy we can save specifically by utilizing such kettle. The electric kettle is favored by many people for its high efficiency and convenience, and it is really popular, especially in areas where there is no access to bottled water. So the efficient use of such kettle is becoming increasingly important, and we are trying to find ways to make it become more energy saving. First of all, let's have a look at the electric kettle in today's market. The so-called energy-saving electric kettle in today's market, their major concern is to enhance the diabatic effect of the kettle's wall to reduce the heat loss during the heating process. However, we consider such measures as somewhat useful but far from satisfied. Next, there is a question: do we actually need to drink water with 100 degrees centigrade? Actually, absolutely not, because your body will refuse you to do so. Even if you want to make some tea or some coffee, you don't need boiling water. For example, the famous Westlake Longjing tea, the best recommended brewing temperature is at around 80 degrees centigrade. But in order to sterilize, we have to boil the water. So the energy loss, the heat loss between the boiling temperature and the drinking temperature is really a waste of energy. So in order to utilize such lost energy, we have designed our electric model. Generally, our electric model is consisted by 3 water beans, 2 magnetic valves, and 1 heat pipe. In general, this kettle will not only be energy efficient or energy saving, it will also bring better experiences to the users than before. Well, this is a sketch of our electric model. And you see 3 water beans, 2 magnetic valves, and 1 heat pipe in the middle. And these are the photos of the fabricating process of our team. And this is another model which based on the same idea. Well, it is really a tough work because all of this work is done by our 2 hands. Well, in this slide, I would specify the working process of our model. First of all, you have to set the drinking temperature. And then you should fill the 2 upper beans with water and then close the valve above. Then you can start to heat the water in the middle can bean until it boils. And then release it to the leathermost can bean. Here, the heat pipe will start do its work by transfer the heat from the boiling water to the cold water in the uppermost can bean. Obviously, the temperature of the water in the uppermost can bean will increase, while the temperature of the hot water in the nethermost can bean will decrease until it reaches the setting temperature. We can remove the water in the nethermost can bean, and then we can open the computer will open the valve above to release the water into the middle can bean to start another heating cycle. This is the inner circuit of our model, which makes those processes stated above possible. We think this idea is really promising because it is not just confined to the electric kettle. It can also be utilized on the homely water dispensers, just like this, or such big boiled water machines in public places. So we are we have been applying for the patent. In this part, I'd like to talk about the innovations inside our kettle. First of all, by setting the drinking temperature, it is really convenient for the users because the users can get what they want precisely. Also, our model have faster cooling rate. Usually, it will take about 10 minutes for the boiling water to cool down to the 60 degrees centigrade. However, our kettle will only cost you 6 minutes. Most importantly, we have utilized the energy released from the boiling temperature to the drinking temperature. Such heat will be used for another heating cycle, and this is the point where we save the energy. As mentioned above, we have conducted several experiments to test the energy efficiency of our model. And this is a photo taken when we are conducting such experiment. This may seem a little shabby. Anyway, the result of our experiment is really inspiring. And this graph shows the change of the temperature during the heat transfer process. The temperature of the hot water has decreased from 100 degrees centigrade to 61 degrees centigrade, while the temperature of the cold water has increased from 22 degrees centigrade to 49 degrees centigrade. According to our calculation, the heat transfer efficiency will be 0.69. And we believe in practical use, if we can minimize the heat loss during the heat transfer process or increase the number of the heat pipes, the heat transfer efficiency will be much higher than this. Also, this is also the graph based on our practical experiment. And we can see in one heat transfer cycle, we can save 17% energy. And the max saving percentage we can get is around 34%. And this must be done on the condition that we continue to boil the water. Well, this is a huge bonus we can get by utilizing this idea. And we think this is really promising. And this is the end of my presentation, and I really hope my presentation has given you a clear outline of our group's project. Thank you all again.
评审请提问。
Thank you for your presentation. I have two questions. Okay, first of all, since you're working on the drinking water, so have you ever considered about the water qualities affecting your heat transfer? For example, if you have hardness water in there, so how did you overcome the falling problem, the falling issues? And secondly, you're working on the drinking water. Have you ever considered about the safety and the security for this type of the method which you develop?
For the first question, actually we are consider the drinking water, and this is what we based on our idea. I have mentioned in this presentation that this idea can be utilized in several ways, and if we use this idea to boil the hot water.
No, I talk about the hardness, into, okay,
yeah,
and also the organic ions. That's going to cause the foreign products, which is going to affect your heat transfer.
Yes. Maybe we can modify our heater by use some nanoscience to remove the effect caused by the hot water. I think. We were just presenting the idea. We can save the energy based on this.
Okay. I have two simple questions.
Okay.
In the middle chamber,
yeah.
You seem to have a design that is completely sealed off. So when the water boils there,
Yeah.
how do you fan the steam? Okay. And another question. In the lower chamber, you mentioned that there's a temperature suitable for drinking.
Yeah.
But I don't see any design of keeping the temperature at the constant.
Yes. For the first question, you mean that actually in our real model we have make some holes to let the heat come out. So the boiling water will cause some damage to the model in a hole. And the second question is that the drinking. Sorry, ma'am. Pardon the second question.
Yeah, how do you maintain the temperature
Yes.
in the lower chamber?
Yeah. We have made this model to present this contest. So we choose a polycarbonate material to make the whole model. This is just for presentation and for you to have a good look at it. But in practical use, we may choose other materials and other measures to enhance the diabatic effect of the whole model.
谢谢浙江大学，谢谢。
Since time is limited, we have already released water into this cabinet to heat, and then as we have set it, we will heat the water to 70 degrees centigrade. Okay. First, we can set the temperature we need. If we would, then in order to present this, we have set the wind. Yeah. 50 maybe. Yeah, it is very fast. And this is the temperature of this water in this can. And it is being heated with this water.
This is the sensor?
Yes, temperature sensor.
I think the concept is pretty good. Question the judge has had in the morning is that will there be some volume or scaling on your heat pipe, and then the thermal conductivity or heat transfer performance will be just degraded.
We have had number of so and we have added some things to increase the rate of the transfer. So the heat from the hot water will be quickly transferred to the water.
But let me share you one information. You can buy one with your concept about $2,080 in Taipei. So you probably will consider to bring one back to Hangzhou.
Your heat pipe goes through the middle section too.
Yeah.
So how do you prevent it from taking heat from the boiling chamber?
The heat pipe, the end and the top of the heat pipe will release and absorb the heat. However, the middle will not, because there is cold water in the top. So there is some liquid in the heat pipe, and when it meets the high temperature, it will evaporate. And when it meets the cold water, it will quickly release the heat. And we already have 70 degrees, and this valve will open and release the hot water into this cabin. And then the heat pipe will do its work and transfer the heat from this cabin to this cabin, which means we preheated the water. That is how we utilize the energy released from the boiling temperature to the drinking temperature.
But you have to make a reasonable assumption as the water is being purified.
Yes.
Okay. That don't have any pathogenic bacteria in there. Okay,
Actually, what happened?
the second one, you have to
Is
any no falling mechanisms in here which are going to affect your heat transfer. You understand, right? 就是说我跟你讲说，这里面人家假设这个水不是这个水它没有任何生物细菌的污染，因为我们通常把温度加到190度的时候，很多 bacteria 它会被我们给杀掉。
Actually, we just to present this, and we can set the temperature at. Actually, in practical use, we will boil this water.